Welcome viewers. I am Venkatesan. Today my lecture is about the pigeonhole principle. If k is a positive integer and k plus 1 or more objects are placed into k boxes, then there is at least one box containing two or more of the objects. That is, in general speech, if m pigeons are assigned to n pigeonholes where m is greater than n, then there must be a pigeonhole containing at least two pigeons. Suppose there are 11 pigeons, let me assume. Suppose there are 11 pigeons and 10 pigeonholes are there. Then at least two pigeons must be there in a pigeonhole. This can be generalized and is known as pigeonhole principle. Second one, the generalized pigeonhole principle. If m pigeons are assigned to n pigeonholes, then there must be a pigeonhole containing at least m minus 1 divided by n plus 1 pigeons, where that square bracket is nothing but the greatest integer function. Let me consider an example. Among any group of 367 people that we consider, there must be at least two with the same birthday. 367 people, at least two with the same birthday. Why? Because there are only 366 possible birthdays are there in total. Similarly, consider one more example. In any group of 27 English words, remember 27 English words, there must be at least two of them begin with the same letter. Why? Because there are 26 letters are there in English alphabet. We have only 26 letters, but the total count is going to be 27 here, which means two should occupy in the same place. Start an example now. Problem number 1 in exercise 2.4. How many students must be in a class to guarantee that at least two students receive the same score on the final exam? If the exam is graded on a scale from 0 to 100 points, so starts from 0. 1 to 100 means total is 100, that we know clearly. 0 to 100 means, first of all, what is the total number of possibilities? That is 101. So solution, there are 101 possible scores are there on the final examination. Next, by pigeonhole principle, among any one or two students, there must be at least two students with the same score. Question number 2. What is the minimum number of students required in a discrete mathematics class to be sure that at least 6 will receive the same grade if there are 5 possible grades: capital A, capital B, capital C, capital D and capital F was given? Solution: number of students, that is considered as number of pigeons, where m is equal to, remember we are going to determine the number of students only, because what is the minimum number of students was the question. So we are going to determine the number of students, that is considered as number of pigeons here, which is m. Second, number of possible grades. What are the possible grades are available? 5 possible grades are available: A, B, C, D and F. That would be considered as a pigeonholes. And one more thing is given in the question: at least 6 will receive the same grade. At least 6 will receive the same grade. Hence, by generalized pigeonhole principle, we are going to determine m value now. M minus 1 divided by n plus 1, which is equal to, right hand side, this is 26 here. Right hand side is 26, which implies, we know that n value is 5 here. So replace the denominator with the 5. And if we take LCM and cross multiplication, you will be getting m is equal to 26. Therefore, the minimum number of students required in a class to be sure that at least 6 will receive the same grade is 26. Problem number 3. Show that if 9 books are to be kept in 4 shelves, then there must be at least one shelf which contain at least 3 books. First, we have to consider the number of pigeons and number of pigeonholes. Total 9 books are there, which is mentioned clearly in the question. See, in the first line itself, it is clearly mentioned 9 books are there. Those 9 books will be considered as number of pigeons, and 4 shells are there. That is considered as number of pigeonholes. What's your question? We have to prove at least one shelf which contains at least 3 books. So by generalized pigeonhole principle, we can prove this. M minus 1 divided by n plus 1 is equal to, replace m value here. We know that m value is 9 and n value is 4. So 9 minus 1 divided by 4 plus 1 is answer 3. Hence, there must be at least one shelf which contains at least 3 books. Thank you.